Hello and welcome to lecture series on electrodynamics. As we are already equipped with the mathematical tools to handle the electrodynamics, we can dive into electrodynamics. In electrodynamics, the basic problem we are trying to solve is to find the forces or the interaction between the charges. So we have, say, a number of charges. So we can say n number of charges, say Q1, Q2, Qn, and we want to find, say, these are source charges. We can call them source charges. And we want to find force on another particle charge we call capital Q and called a test charge. We want to find the force on test charge Q due to uh, charges Q1, Q2, Q3, Qn. So for these charges, we are, say this is XY plane or any plane. So we have charge Q1 here, where we are given the position vector R1, and so on. We have Q2, and we are given R2, and we have somewhere charge. This is R, and this is charge. This is position vector of the test charge. So we will denote R prime with for sources and R for the position vector. And the separation between these two vectors is denoted by separation vector. So the fundamental problem is to find the force on charge Q due to all the charges that are Q1, Q2, Q3, Q4, Qn. So the position vector is given and it's function of time as the charges are moving, both the test charge and the source charges are moving. So we have to find the interaction or the force on Q1 due to all force charges. So it seems very complicated problem to have one test charge and we have so many charges. But there is a good news. That good news is that electromagnetic force follow the superposition. And what is superposition or superposition principle? So superposition principle says if you find a force due to Q1 on Q and say this is F1 Q this is F1. So it is F1 is independent of other charges. So it only depends on Q1 and Q and also the position vector or the separation vector. So the force F1 is unaffected by any other charge. So that means if we want to find force due to Q2, so Q2 is F2 due to Q 2, and it is unaffected due to Q1 and Q3 and so on. So on, if we want to find n number of charges and then superposition again, says the total force will be sum of the forces due to those independent single charges. So you can say the total force is independent, is the sum of the force due to Q1, due to Q2, Q3, and so on, Qn, and the net force on charge Q is the sum of all the forces. So this way, we have to find only one thing, and one thing is to find the force of just for two particle system, not for n particle system. If we find the force between Q, single Q and Q, then the superposition says we can find individual charges force and then we can add them up. So the problem turned back only for just for two particle system. But as the charges are moving, they only not depend upon the separation vector, but also the force also depend upon the velocity and acceleration also. As charges are moving, they can have velocity and acceleration. So it's not still not a straightforward problem, but for this chapter, we assume that charge velocity and acceleration is 0. So charges are at rest. So with this assumption, we try to solve the problem in this chapter, and we called electrostatic. This part, when we assumed the charges are rest, so we will be solving the electrostatic problem. And later in chapter 11, we will chapter 10, we will try to solve the problem with the moving charges where we have velocity and acceleration. So we have to answer only two particle system and the force between two particle system. And here comes the Coulomb's law. So section 2.2.1, Coulomb's law. So Coulomb's law says if you have two particles, two charges, and they are Q, and this is again R prime, this is Q, this is R, and the separation vector we will denote with other R. This is so as per Coulomb law, which were the again experimental observation, the force between the charges, the magnitude is directly proportional to magnitude of the charge and inversely proportional to the distance between the charges. Again, it's a magnitude. So together it says F is magnitude is proportional to Q divided by R square, and F magnitude is equal to 1 over 4 pi, which has constant of proportionality and also denoted by K. K is equal to 4 pi epsilon naught, or 1 over 4 pi epsilon naught. Sometimes they use just K here. So where Q and Q's charge magnitude of the charges, R is the separation vector, and epsilon is constant, and its constant is have value 8.85 into 10 to the power minus 12 Coulomb square per nanometer square, and it's called the permittivity of the free space. So we define, as we know that this electrostatic force is a vector quantity. We define just magnitude, how to define the direction of the force. So as we have two charges, so direction of the force will define with the direction of the r vector. So this if we have same charges, as we know from elementary physics, so same charges repel each other. So this charge will exert force in opposite direction. So this will be direction of our unit vector, of the force. Force will be in this direction. And if we have opposite charges, so opposite charges attract each other's. So the force direction, this charge is pulling the charge here. So the direction of the force will be in this direction. So depending upon the polarity of the charges, so direction can be assigned, or in other words, if you have the same charges, this R is positive. So R is positive increasing outward, and we have the opposite charges. There will be a negative sign, that's mean is inward or in opposite direction. The better way to understand is just to see the charges, polarities, and then you can decide the direction of the force. And R is R prime, R minus R prime. And magnitude of this will become R minus R prime mod. And if you want to find the unit vector, then it's straightforward, vector divided by prime, the magnitude of the vector. So this way we can find all the quantities involved in this force. We need separation vector, we need unit vector, and then we need the amount of charges. So for electrodynamics, now we have the two things. The one is the Coulomb's law. The other thing is superposition principle. So these are the two things we know for electrostatic. So if we have number of charges, the first we have two charges. So Coulomb's law is going to tell us the force they are trying to exert on each other. And then if we have a superposition, then we can find the force on any point charge due to any number of charges. So these are two basic ingredients of electrodynamics. So if we know the Coulomb's law and superposition principle, we are done with electrodynamics. So all we do, try to solve or try to put a problem in a way that we can solve it easily. So this is the basic theme of electrodynamics. Coulomb's law, interaction between two charges, and then superposition to add all the interactions. So we will continue with next section, and hope you will join me in next lecture too. Bye.